This is Remote Ruby.
Have you any remote idea to the meaning of the word?
Christopher, Andrew, hello.
Yo.
How you doing?
I'm swell. I took a mental health day yesterday and read a book and went to dinner with the family. I feel rejuvenated and I have a lot of basketball things to talk about, but not today. So how are you?
That's good to hear. It feels weird that we're recording on a Thursday instead of a Friday. So it feels like Friday to me.
It's Friday.
Tomorrow will be disappointing, right?
Is it too late to take a mental health day? That's what I'm doing the math of.
Andrew and I, we can talk about this on another episode, but Andrew and I have been pairing this week on GitHub Actions. And so I feel as this week I have been living in Phoenix with Andrew, living in Andrew's brain rent free.
Yeah, there it is.
Well, there it is. But we will stop our banter right now and get to what is a very exciting episode for us. Today we have José Valim, went for it. And we have Seth Horsley with us, who actually was pretty instrumental in setting up this conversation. So if you're unfamiliar, creator of Elixir, former Rails core contributor. And so welcome to Remote Ruby.
Hi, thanks for having me as a guest.
Maybe we could just kind of start off with maybe just kind of a quick introduction.
Yeah, so I am a Brazilian person living in Poland. Now at this point, a long time ago, I was part of, as you said, part of the Rails core team. I was very active in both Ruby and Rails community for a while. I was lucky to be invited, for example, to visit Japan, speak at Ruby Kaigi. But right now at this point, especially with what has happened in the last 2 years, it pretty much feels like a past life. And over the last 10 years, a little bit more, I started working on a new programming language called Elixir that has grown to be its own thing, its own community, with our own events around the world and with our own everything, web framework, all machine learning tools and everything. So, and that's what I have been working on for the last 10 years. So I'm really glad to be able to be here and talk a little bit more about everything.
That's fantastic. And Seth, too, I want to give you an opportunity to maybe introduce yourself and how you found yourself on a Ruby podcast with the creator of Elixir.
Thanks for having me, by the way. I went down to New Orleans probably about a month ago to the big Elixir conference. And it's kind of a spastic move. Like a week or two before that, a buddy of mine who learned Rails, he's like, let's go down. We went down and there were a couple just excellent talks. Conferences are usually amazing. But after being inspired there, I talked to Marlus, who used to work with José. And I asked him, like, what are the odds José would be willing to get on a podcast? He said, just ask him. Super friendly guy. And if he doesn't answer, tell him that Marlus said to contact him. So that's kind of how this spun together.
It's awesome. Well, yeah, thank you for helping organize this. This is fun. Lots to chat about. And I think maybe kind of relevant to get us started. So Ruby developer for a long time. I think my first introduction to you may have been Devise, actually. If I'm not mistaken, you were pretty core piece in all of that to get started. So how maybe did you get started in Ruby and progress into being a Rails core team member?
So it's so funny because it was a long time ago and a lot of it has changed. So just to put things into perspective, when I started, GitHub wasn't a thing yet, for example. So I'm just saying this because not to call myself old, but because like a lot of the things that are particular to my story, I'm pretty sure they're no longer relevant today because so much change in terms of what it is to collaborate around software. But to make like a long story short, due to Friends University, I was put with Rails and I started to learn it. And I've always been the type of person who likes to go in deeper and try to understand how things work, how things connected. So I was always looking inside the code. Slowly, I've made my contributions. Here, a small patch here and there to Rails, made like my first packages. So I think it's pretty much not used at this point, but I think the first big package I made that got a lot of use was inherited resources. And I have like deprecated it a long time ago, but I think somebody undeprecated, I don't remember. And then what was happening at the time, this was 2008, 2009, it was like the Rails tree rewrite. And one of the big things about the Rails tree was that it wanted to be like agnostic in terms of like, well, if you want to bring a different ORM or if you wanted to bring a different test framework, which was a very big discussion at the time because of our spec, you should be able to do those things. And there was a Google Storm of Code, and I submitted a proposal to write, I don't know if it's used today, probably it is, the infrastructure for pluggable generators that would be part of Rails 3. They accepted that proposal. And then again, because it was before GitHub or around GitHub, I did not have like direct contact with the team. So Google Storm of Code was my opportunity to have a direct contact with the Rails core team. And then I've made friends. I was, during a long period of time, really close to Yehuda Katz as well, which is also an alumni member of the team. And then I was getting familiar with everybody. I was getting more opportunities to contribute under my plate. And eventually I was invited to be part of the Rails core team.
That's a very like cool natural progression. Just like kept doing work and all of a sudden making friends and on the core team. I love that. So Platforma Tech was a very like influential company in the Rails Ruby space, and you worked for them, correct?
Yes, I was one of the founders of Farmbot Tech. Yeah,
so
I was
more than working. Yes.
Yeah, I think at some point we had 3 Rails core team members at Plataforma Tech because it was Carlos Antonio, Rafael França, and myself. One of the reasons why they joined us was exactly because we had a name in open source, and I was also working there. So I hope they were excited to be working with me too at the time. But Rafael, for example, I'm sure that he has surpassed me in terms of contributions to both Rails and Ruby. So that's pretty nice. I was part of Plataforma Tech, and Carlos Antonio, I think you mentioned Devise. He was the one who started Devise, if I remember correctly. So we did a lot of awesome work together.
Cool. Authentication is a touchy subject on our podcast. I would like to talk to you when we get there about authentication, because I know you've just done quite a bit of work with Phoenix and building kind of a scaffold for that, but we will save the triggering conversations for the end. Okay, so Rails core team member to creating Elixir. How do we get there?
Yeah, let me just tell a story because it's a very weird story, but it's such a fun segue that each of what we need to do. So I met someone at an Elixir conference, and the person told me, he was very nice about it, because what I'm going to say, like, it can go wrong in so many ways. But a person came to me and said, when somebody told me that the creator of Devise, or like the main contributor to Devise, created a programming language, I put zero faith in that programming language. But when I checked it out, he did not say like this, but he wasn't like in a good mood. So again, like I say, like, but when I checked it out, I really loved Elixir. And then I was like, I couldn't resist but laugh, right? Because it's just like such a weird thing to say, right? But I was like, all right, I guess I'll take it. But yeah, so how do you go from one to the other? I'm going to tell a reasonably long story because I think the subject deserves that. So when I started Elixir, I did not have, like, everything that I'm saying, I did not have this whole perspective. So there is a little bit of like, of growing throughout the years to be able to look back and say, okay, here's the situation that I actually was and why that worked and why some things didn't work. So we are going to go back to about 2005, and it probably took me like 7 or 8 years for me to read this paper. But in 2005, a paper was published, which was called "The Free Lunch is Over." And the idea of this paper, it's a very influential paper in terms of like dictating where we are going as a programming in general. So what was the free lunch? So in 2005, like way back 2005, if you look back the last like 3 decades, it was great for being a software developer because we have something called Moore's Law, which basically said that every 2 years, we'll be able to double our processing power in a cost-efficient way of producing new chips. And what that means is that every 2 years, you'll be able to go get a new computer and that thing would be twice faster. And the pre-launch was that for us as developers, it meant that we could not work on the software for 2 years, but everything was getting faster and evolving at such a pace that in 2 years, everybody would have like faster machines and our software would like effectively run twice faster, which is great. Great time for being a developer, right? You could do nothing in 2 years. You can kind of say, hey, everything is faster now. And everybody would get that perception. And what the paper was telling us is exactly like, hey, that's the free lunch and that's over. This thing that we are doubling like the processing power, like it's cost efficient to do so, it's no longer going to be true. And that's the situation that we find ourselves over the last several years. We don't have a machine with 8 gigahertz, 16 gigahertz. It's where we're supposed to be if the progression was continuing. And then he was saying like, we as software developers now, like we are going to go into a multi-core future where we're going to start to have machines with multiple cores. And again, that's the reality we have today. Like I like to say, like you get an Apple Watch, for example, like your watch has 4 cores. We will say now we are in the situation where our machines are going to start to have multiple cores. And if we want our software to continue going faster as we add the number of cores in our machine, as we go into this new progression, which is about growing the number of cores, we need to change the way we write software, right? There is no way around it. We have to change. It's a whole new paradigm, a whole new approach. And that was the paper. And I was not aware of it at the time when it came out. When I first started hearing about multi-core and concurrency was within the Rails community. We started to hear more and more that people we know, they wanted to deploy on machines with multiple cores. And I think the first time that really caught my attention was, I think it was like Rails 2.2. So it was like a long time ago. And in that release, one of the big features was that Rails was thread safe. So let's break this down a little bit. What it means for Rails to be thread safe. In a programming language like Ruby, in most programming languages, actually, one of the ways that if you have a machine with more than 1 core, one of the ways that you can use multiple cores within the same program, the same software, is that you start threads. So you're going to have multiple threads and then some can run in 1 core and other threads can run in other core. And what that meant was that if you deploy a Rails application on something with multiple cores, you can now use threads, and that's going to be safe. And today, I like to joke about the word thread safe because like safety is like the lowest guarantee possible that you can give in software. Imagine you being a software consultancy or something, that company that builds software, the right software. Then somebody says, hey, I want you to write this software for me. And then they ask at the end, is it going to be fast? And you're like, I don't know. I guarantee that it's not going to have a segmentation fault. That's the right. Or is it going to have a good user experience? And you're like, I don't know. It's not going to have segmentation fault, right? It's like, it's the lowest possible guarantee that we could potentially give. To the point that back then, when Rails was made thread safe, I was not part of the Rails team. When Rails was made thread safe, what they did is that they put a lock around your Rails application, which meant that if there were 2 requests coming at the same time, you would still serve only 1 request. You were effectively not using the cores. You're not using the machine resources available. And then later on, I joined the Rails core team and we tried to improve with time, right? We tried to improve the situation to not have a whole lock around the application so we can actually try to benefit some of the concurrency. And then we worked on all those features, me, other members of the Rails team. And I remember we would run into situations. So there is one issue report that I received. I mean, it has more than 10 years ago. And I still remember kind of like the details a little bit fuzzy, but I remember somebody was saying, look, we have a Rails application in production and we also have auto scaling. So when we have a spike in production and auto scaling kicks in and starts a new Rails instance, we get some errors. And then the Rails application has errors during booting. And then they were like, we know like this is related to concurrency, to threads, because there was a flag that you could enable. And then imagine being on a team, you receive a bug report, like the bug report was great, but I'm thinking like, hey, how am I going to tackle this problem, right? Because first of all, how am I going to reproduce it? Because it happens when autoscale kicks in. So what most likely is happening is that when there is a new instance in production, because Rails like to lazily initialize a bunch of stuff, what's probably happening there is that they put a new node in production, a lot of requests come at the same time, and because it's running on different cores using different threads, it's going for a particular code path that is making things blow up and not behave the way it should. So first, how I'm going to reproduce it, and then how I'm going to debug it, how I'm going to fix it, and how I'm going to make sure that I actually fix the thing, because everything like is very specific and very particular to one detail. So at this time, I was looking at this and I was thinking, look, if concurrency is going to become the future, because everybody's talking about it. So this is like 2010, I think, or maybe 2011. If concurrency is going to become the future, I need to have better tools than I have right now for dealing with concurrency. My first idea was, you know what I'm going to do? Like, if this is going to be such a big deal, there are likely other programming languages or the frameworks, whatever. There's probably going to be something that has a good solution to this problem. So I didn't start like set out to create a new programming language. I mean, 99.9% of the people, right? They don't. First, like, hey, you know, what is this problem and what are the possible solutions? So I went on a journey to learn how to solve that problem. And I like to say that in this journey, there were 2 points, 2 things that happened that completely changed like my career, changed my perspective about software development. So the first thing was when I found a functional programming. And functional programming can mean a lot of things to a lot of people. So I'm not going to rely too heavily on that. So what it was for me, functional programming, the whole idea was the idea about immutability. Okay. So what does that mean? So like in Ruby, for example, if you have like an array and then you delete something from that array, you go and you change that array memory. You just go and you change and you mutate that array. In functional programming languages, or better, languages that are immutable by default, if you have a list or an array and you remove an element from that array, you're not going to change the array in memory. It's actually going to return you a new array without that element. So we are always transforming. We are not mutating things anymore. We are transforming all the time. And why this is such a powerful idea? There are 2 reasons that I was so convinced by this idea at the time. When I looked at immutability, I was like, this makes total sense, right? Because one, when I was working on like those issues with concurrency, a lot of the issues that we had with concurrency was exactly, imagine that I have 2 threads running 2 cores at the same time. What is going to happen if they try to change the same place in memory at the same time? That's why the software gets corrupted, right? Because you have 2 threads trying to change the same place. And that's why like Ruby, for example, has a global interpreter lock to safeguard all the operations that it's doing internally. So I was like, wait, if we are no longer mutating things, if we're no longer changing things in memory, a huge category of issues that I had related to concurrency, they are simply no longer going to exist. They're going to disappear. For me, is the best way to solve a problem. I mean, I can have a problem and then I can have the solution for that problem. I have the problem and the solution to the problem coexist, or I can remove the problem altogether. And this was like removing the problem altogether. And I was like, this is beautiful. This is great. And then I was like, oh, I want this. And the other thing is that a lot of people, they focus on immutability for concurrency. But to me, you get more readable, easier to understand software if everything is immutable. Like how many times in Ruby you call a method and that changed something in another object that you're not expecting, or even something simpler like you pass like a hash to a method, for example, and that thing like removes things from the hash or add things to the hash behind the scenes that you are not expecting. So if everything is immutable, all those kind of things, they disappear as well. Like trying to understand, hey, when I invoke this thing, it's changing all those other parts of my system. So I was like, okay, I'm convinced. I want to have immutability by default. That was the big deal for me. It was like, I think my software is going to be more readable. It's going to handle concurrency better. That's what I want. So I started from that moment. I was able to focus a little bit. I was like, okay, now I want to learn more about languages that are immutable by default. And most of them are functional programming languages. So I went to study Scala, Haskell, Clojure. I went to learn about a bunch of different languages until I eventually found Erlang. And Erlang was the second point of no return in this journey. And I'll tell you why. Because for those who are not familiar, Erlang is both like a virtual machine, like Java. We have like the Java language and the Java virtual machine. So we have the Erlang programming language and the Erlang virtual machine. And it was created by Ericsson in the 80s. So it exists for quite some time to solve telecommunication companies. They're building telephone switches and this kind of stuff. And the thing about that is like, if we go back, so this is like 2010, 2011, if we go back 10 years and you see at all the languages that were appearing at the time, Elixir included, all of them, they were talking about concurrency, right? So you look at Go, you look at Swift, F#, Clojure, they all had a concurrency story. They're all prepared like for this concurrency future that I was talking about. But here's the question, like, okay, imagine that we get a programming language that is great for concurrency, that regardless if I have like 4 cores on my machine or 32 or 64, it can use all the cores on my machine efficiently. What happens when one machine is still not enough for you to do everything that you want to do? Like you cannot do everything on one machine. You need to add another machine. And now you need to have 2 machines or 3 machines or 4 machines working together towards a common goal. So what we have when you have like those machines connected together and communicating, you have a distributed system, right? You want the machines to communicate with each other. And that's the problem that Erlang solved. And not only they solved that problem, they solved it like 3 decades ago. And the design is so interesting because the way that Erlang solved it is that they think like concurrency is the special case where everything is running, is a special case of distribution, is when everything just happens to be running on a single machine. So I looked at that and I was like, you know what? Everybody's trying to solve concurrency. Everybody's saying, hey, here's my answer for concurrency. And we have this platform that exists for like 30 years that not only solved concurrency, but they solved the next thing. They saw like the next problem that everybody's going to have. And I fell immediately in love. When I look at that, I was like, whatever I do, like the next software that I write, I want to run on this environment. And then you mix this with other stories that were coming at the time. So WhatsApp, it's possibly, Erlang has like absurd use case, like more than 50% of all like 3G and above 3G traffic in Europe is going through Erlang machines. So it's a massive scale that this thing is operating. And then we have like WhatsApp that is built on top of Erlang as well. And WhatsApp, they have like more than 1 billion users. In a day in WhatsApp, you have more messages than the whole SMS system. And this was like 5 years ago, okay, those stats, or even more. And they're using Erlang and they were writing about it. They were going to articles and conferences and talking about it. So when I look at that, I was like, this is amazing. I want this. So I started going into Erlang more and more, learning more about it. And I say that I loved everything I saw, but I really missed the things that it didn't have. Like there were some things that I thought was really important for me as a software developer or somebody who has worked on a framework for me to create abstractions that I felt it was missing. And that eventually led me to create the Elixir programming language. And the whole reason why Elixir exists, it's because of the Erlang virtual machine. It's for me to be able and to leverage all of the power that the Erlang virtual machine has to offer.
So that's a pretty amazing journey and really fascinating to hear how Elixir came about, like through the progression, because I think it's easy as like people from the sidelines to be like, oh, you just wanted to create a programming language and you did, and it's amazing. But like, there's a lot of history and context here that is really important. And the choice to use Erlang has always been really fascinating. And so like, I didn't hear about Erlang until I heard about Elixir. Then now all of a sudden I'm installing Erlang on my computer. So yeah, that's really fascinating. So once you've kind of got a foundation, like an idea of Elixir, what's kind of the story like around putting it into the world? And we can talk about maybe some of the features that have grown in it, but I'm also curious about like the adoption. How's the reception, things like that?
Yeah. So one of the things that I've learned as part of being the Rails core team, sometimes developers, they don't like this word, but it was a lot about marketing. And not like the silly marketing, but the realization that somebody can build like the perfect programming language, which doesn't exist, but somebody could create it. And if they don't tell anybody about it, if they don't go to events, if they don't write about it, nobody's going to use it. That's the state of thing. There was some period that I was like prototyping and I was not like confident that Elixir would ever be a thing. But from the moment where I realized like, hey, actually there's something in here. And it was clear to me that I need to talk about it. I need to go to events. So I set up like personal milestones like, hey, I want to go to an event and give like the first presentation about Elixir and get people to know about it and incentivize the community. And there is something that we have also done throughout those 10 years is that we also have to focus a lot on the getting started experience. A lot. And there's something also that lessons that also I probably got from Rails. And there were other languages at the time doing this really well as well. Like Go, they always had that notion of Go being like a unified tooling via the command line. Because you think about it, what we are asking people now is like, hey, this is a functional programming language, which they probably have never used one before. And you can use this for writing like concurrent and distributed software. It's like so many question marks in there. And if we don't worry about like the user experience, like when you hear about Elixir, for example, in this podcast and you want to try it out, we want to make sure that you are going to try it out and you're going to get victories, small victories out of it, get feedback, get something running. So this was very important in this journey of getting Elixir to grow and getting Elixir to be adopted more and more.
Would you consider yourself like a web developer before you got into writing Elixir? We know you from the Rails community, and I'm kind of curious, how much of a struggle was that to go from writing Ruby all the time to actually writing a programming language, which I would assume is a lot more complicated and a lot more other things to worry about there, but maybe not. I'd love to hear your answer.
I was definitely a web developer. And we can talk about this later, but I was like a falling out of love web developer. I was joking about being old, right? But the first thing I did with programming was a website for the band I had university. And at the time it was like, I did in Macromedia Flash, which is pretty much dead today. And Macromedia was acquired since then. So I started with web and then I did a little bit of PHP with MySQL before eventually getting down to Ruby. In like the last 20 years of web development, like so much has changed. And a lot of it was like complexity that we acquired. But complexity is not necessarily like bad by itself. So for example, I would say like if somebody's learning to program today, they are most likely learning Git from day one or very close to day one, which is like, it's more tooling, it's complexity. But I would say like it's essential complexity, right? Because when I started programming, I did the usual thing, which was like I would have a file and then I would have version 2, version 3, version 4, version 5 final, version 5 final, and then version 5 final for real. So I've gone for this and then like, no, version control is good. We want to have that. But when I started working on Elixir, I was like pretty much falling out of love because we were in a situation where when I started, I needed a database and my web server. That's all I needed. I didn't need anything else. But we were in a place where now, well, I need Node to be able to catch up with like the latest advancements in CSS and JavaScript. Or if I want to do any kind of thing that is like interactive, I most likely need to bring Redis or something to manage. So, like I started to see like that thing that for me was so simple. And now I wanted to get started in a project. I had to install so many things on my machine to get that installed to the point that today we have like Docker running on our machine to automate all the many things that we have to install. This ball of complexity that keeps rolling. But yes, that's a parenthesis, right? So I was definitely a web development, a little bit falling out of love with that. I had a couple insights at the time and I was still working at Platform Attack. And Platform Attack was also like a web company, but I didn't want Elixir to be a web programming language. And there are some programming languages that they are like, hey, this was designed for the web, that were like explicit purpose with that explicit purpose. And I was like, no, I want Elixir to be like as a general programming language as it can be. So I was very careful to not have any like web specific bias in Elixir itself. For me, it was very important that instead of having Elixir being centric, like, or being specific for the web, I wanted Elixir to be a programming language that we can grow, that we can extend, and somebody who is not like in the Elixir team can get this programming language and bring it to the web and be able to like mold it so it's really good for app development. Because if we focus on having those abstractions, then somebody can get Elixir and bring it to a whole different domain, to have to bring to a bunch of things that I would not be able to think about. And we saw this happening later on. So I was really careful about it, especially because we run on Erlang, the Erlang virtual machine. It means that we are also already, by default, we are good at like building distributed applications, for example. So I wanted to be sure that we would not like break our Erlang heritage, and then we could grow to new domains and new areas. So there was a lot of effort into that direction, but also, as you said, a lot of learning, because I don't have a computer science background. So if you're building a programming language, there are like things that are common to compilers that today I'm very familiar with like lexirs, tokenizers, grammars that I had to learn. I always joke that I've bought like the Dragon book, which is a book with the dragon on the cover, like classic computer science book about compilers. But I've read like until like page 50 or something like that, because I would start reading and then because like I need to learn those concepts. And then I would learn something. I was like, oh, that's the answer I needed. I would get very excited and I would go and work on the thing that I wanted to work. But definitely a bunch of learning there.
Hi, my name is Andrew Mason, and I'd like to tell you about Honeybadger. Whether USDS 1 is down or you forget to add a configuration file, everyone has an outage from time to time. When your next outage occurs, transparency is critical. The difference between a minor annoyance that people soon forget and a fiasco that creates sustained resentment is how you communicate. That's why you need Honeybadger. Honeybadger is a crucial component of your incident response plan with their uptime monitoring service that now has an exciting new feature, public status pages. Create a new status page with custom domains, branding, and more. Don't let Twitter be the only way your users can find out if your app's down. Sign up for Honeybadger to improve your incident response with a shiny new status page that you'll be proud to show users. Visit honeybadger.io and start giving your users a better experience today. Let them know that Remote Ruby and specifically Andrew Mason sent you.
I'm really curious, like how long do you think it took you to get from starting Elixir to where you were like, this is stuff that people are running in production and you feel confident in it? Because I feel like there's probably a fair bit of time that goes between that where it's like, yeah, you can definitely use this. It's kind of a new thing, but at some point it feels stable. It is stable. Like people are running it in production and feels much more final at that point. How long did that take?
Elixir, like the first commit was in 2011, but at that point it was like just prototype, just for fun. I definitely would not have told anybody like, hey, use this. Mostly for learning, for me to learn how to build a programming language and things like that. And then about a year later, I was able to kind of have a vision of like, hey, this is what this programming language could be. And if this programming language becomes this, then I can tell people like, you can use this because I think it's good. So this was in the beginning of 2012. And the first time where I felt like, hey, this is going somewhere for real was in the middle of 2013. So a year and a half later, me working pretty much like, half of my time in it at least. But it was in 2013 when both O'Reilly and Pragmatic Programmers, they decided to announce like 1 week of each other that they were writing a book on Elixir. And the Prog was actually Dave Thomas, who wrote like the first big Ruby book in the West, right? So that was like when it was really clear that was like, hey, I feel like this is going somewhere. Gave a lot of confidence. There were people who were deploying it before, but it was still at that point that when somebody told me like, hey, I'm running out in production, I would be like, you're doing what? My reaction was more like to be like, are you sure? Than like to be happy about it. And then from there, like the community started to grow. And I think it was 2014 where we were able to release 1.0. And at that moment, it should be like, hey, like the water's warm, everybody can jump in.
I know we could like do a whole episode on this, so I don't want to necessarily like spend too much of your time here, but I'm curious where Phoenix comes into play here. So Phoenix, if anyone's listening, not familiar, a very popular web framework for Elixir, because I know Chris McCord, if I'm not mistaken, kind of spearheaded that, but you work pretty closely with Phoenix. So I'm just curious the story of how it came to be, and if you find it kind of any kind of crucial part of the story for Elixir.
I love telling this story too. So I've worked on a web framework before. I wrote a book like Crafting Rails Applications about Rails internals. I'm 100% sure it's like 95% outdated at this point, but I had the knowledge, but I was like, I did not want to do it. So first one, like I wanted to be like, again, I think it was good to separate my language bias from the web framework bias and not mix that as I was telling about. And the other one is that I really didn't feel like I would be able to do a very good job about it. And the reason is because like I was like too close to Rails. So I don't think I would be wise enough to, because now we have like, I don't know if I put emphasis enough on this, but we have this amazing platform, the Erlang Virtual Machine, that was built for telecommunication. And web applications, it's telecommunications, like reading things from a socket and writing things to a socket. And we were hearing about WhatsApp. So for example, WhatsApp, they were running Erlang in production, and they would write how they were able to get like 2 million devices, like 2 million phones connected to a single machine, one machine only. So, I was looking at those things and I was like, there is a big opportunity here. And I am too close to the problem. I'm not wise enough to look at these and see what are the opportunities, the actual opportunities that are lying here. At the time, there were other frameworks popping out, and a lot of them felt like Rails in Elixir. And I don't think this is necessarily bad. But for me, I really felt like there's something big here. There's a big opportunity for us to rethink how web development should look like. And somebody's going to see it at some point. And that person was Chris McCord. It's actually interesting because he was trying to write a real-time application in Rails. Again, this is like 2013. So he went through all the pain points of like event machine, getting threads to work, stumbling on the global interpreter lock, keeping connections alive, all those things. I don't know what is the status today, but he ran into all these problems. And he was not able to use it to build like the real-time platform that he wanted. And then he heard about Elixir and he heard all those amazing things about Erlang. And then he was like, I feel like I can do it in this platform. So his first proof of concept, so when he started like Phoenix, the web framework, he did not start with models. He did not start with fields, right? He did not start with controllers. The first thing that he did was Phoenix channels, which is bidirectional, like an open communication channel between the client and the server. The client, in this case, at the time was still like writing JavaScript, but the server that you have your channel code, Elixir code. And that was like his first prototype, his first proof of concept that he did. And he was like, hey, this works. I can build a real-time application. And then he went to slowly build all the rest around it. So when we were at Elixir Conf and he gave a presentation, I was like, this is it. This is what I've been waiting for. Like somebody to look at the platform and say, what this platform can do for me instead of what I can do in the platform. So I was like, this is fantastic. And then I started to participate more in the project, more in the things like the vision is all crazy, but like how to architect the code and how to structure some of the more internal components, which is the thing that I had a ton of experience with. So yeah, I contributed a lot, but the vision is 100% Chris. Oh, and just to finish this story about how amazing this is. And then after we started working on Phoenix, and we have this thing where we have like WebSocket connections to the server, we tried to reproduce the WhatsApp benchmark where they were able to get like 2 million connections on a single machine. And we were able to do that with Phoenix. And it was amazing. And the hardest part of making this work was actually that we had to get like 40, 50 different machines to work as clients so we can send 2 million connections at the same time. And the only reason why we did not went above 2 million is because we had hard coded in the benchmarking tool to stop at 2 million.
Wow.
And then we had a small interface that we could use. And then I went to that interface. I got a whole Wikipedia article and I sent it to the 2 million thing, the people connected. And we could see a spike in the machine, in all the CPUs. It was a machine, I don't remember, like maybe 40 CPUs, maybe more. Right? I could see a spike on all the CPUs being used, but it was like a 2 seconds spike. And that was it. Like I sent a Wikipedia article to 2 million people just like that. And boom, done. So it was like a really cool moment.
I know being able to replicate that, I can't imagine how cool that feels. And like, it's just like building up your confidence and like what you've built. But it also goes back to, it's a really good marketing piece too for the language. Cause I remember that article coming out and being like, this is mind boggling. And that's actually one of the things that was like, it's probably when I ordered the Programming Elixir book is like, okay, like this isn't here to joke around. I don't know. I think it's really cool how Chris like came in. It was like, I want to do this. And Phoenix is a pretty amazing tool. And also leading the way in things like we've talked about on this podcast for like live view. I feel like trying to cut down on JavaScript complexity by relying on WebSockets. If I'm not mistaken, like my first time hearing about it is live view. I assume live view is like one of the first to do that. But then we have all kinds of other languages and frameworks now using those type of abstraction ideas. And it's really phenomenal.
There is also a funny story about LiveView, which is like the first conversation I had with Chris about LiveView. It was not called LiveView at the time, but the idea was actually in 2015. So, and I think when was LiveView launched? 2019 maybe, or 2018. So it was like a good amount of time before, but we did not have the whole vision of how it would look like. And Chris was able to get the whole final vision. But yeah, like when we announced LiveView, it was like kind of this phenomenon where everybody started doing live view like solutions in a bunch of other platforms. But I still think that live view is still unique in very specific ways that it's hard to reproduce in other platforms. And it's not because of like me, it's not because of Elixir, but again, it's because of the platform that it runs on. So we can actually go a little bit back in time because like what LiveView is doing, and a lot of people like to sum it up as like server rendered HTML. But in this case, like you want to render HTML like interactively as the user, not for a full page navigation, but as the user does some action, or, when somebody sends a message, you want that message to appear to a bunch of other people. So it needs to be interactive in real time. And the thing is like this type of like having the server rendering HTML to like update something interactively, this is also like nothing new, right? There's nothing new about it. Like if we go back to Rails 15 years ago, we had something called like RJS, which was, I think it was JavaScript that we would render on the server, and that JavaScript would make changes on the page. So those ideas, in a way, they are like quite old. So there is a question to ask, which is like, why is LiveView different? And why does it matter? What is different now? What is different from this iteration? So we tried server-side, like dynamic server-side rendered HTML in the past. And ultimately, we failed. And the reason why we failed is because here's the applications that we would be building. You would like render the page, and then we would say, well, when the user clicks this on the client, like click a button, I'm going to send a message to the server, and the server is going to say, look, I want now you to go and find this ID, find this whatever on the page and update it, append it, replace it. So it's a very fragmented model where you have all those pieces kind of like poorly connected because one is on the client, the other is on the server. Like, hey, when I click a button, it's going to go to the server, and the server is going to generate like a patch instruction, like go and change this on the page. And this is problematic because, maybe somebody goes and changes the ID, or maybe somebody changes the placement on the page, or maybe somebody changes how that element is first rendered, but they forget to check how the updates that you want to send over the wire are rendered. So it's a very fragile model. And that's why we tried this so many times on the server and why it always failed. Because as the application grows, it's very hard to maintain this. And it's also even hard to test because, you are testing patches, right? How are you going to test that the patch that is coming from the server, how are you going to test that automatically? You need to go and test by hand. And then, well, imagine you have a page, how that page is going to look like after the user is using it for a while and you apply like 15 patches in different order. It's a very hard programming model. So I think even Hotwire that is recent, they have like a feature called like Turbo Stream, where you're rendering HTML. So we are no longer rendering JavaScript, which is most likely better. But a Turbo Stream is still giving me patches to apply on the page. Say, hey, go there and replace this. Go there and add this thing. Go there and delete this thing. I don't want that. We tried this model and I've built large applications with it and it was a nightmare. I don't want any of this. I don't think this is a good programming model. We need to go to something else. So what LiveView does differently. Oh, and before we go into what LiveView does, if you look also at like web frameworks on the client, they also went through this progression. Like if you look at React and why React broke away from the frameworks of the past, it's because the frameworks of the past, they were still kind of like still patching. Hey, when I do this, I want to go and update this thing on the page. And what React said was like, you know what? You change your state and we'll render the page again. You no longer need to say, hey, go change this, go change that. Just change your state and we are going to render the page again. And LiveView, if somebody could describe LiveView as React on the server, and it would be like a horrible way of describing LiveView, but also like a great way of describing LiveView at the same time. Because the programming model is the same. In LiveView, imagine you're building a to-do list and you want to add a new item to the to-do list. You change the state. You go to your list and say, hey, there is a new item here. You put that in the list and you're going to render again. You don't have to say, now go and add this thing to the container without to-do lists. No, the rendering code is all the same. You just change your state and the rendering code is the same. You don't have to worry about it. But then you can say, well, José, isn't that kind of going to be slowful if every time, like when I add something to a list, like to a to-do list, or if I'm on a form, I'm typing on a form and I want to show live validations, telling the user if the input is good or bad. If every time I'm doing all those things, if I'm rendering the page all over again, isn't that going to be like slow or use a lot of bandwidth or, be just weird in the client as well, for a little bit laggy? And yes, you are correct. If you think that would be slow, that could potentially, if you have a form with 15 fields and they're sending everything all the time, yeah, that can potentially get pretty slow, or not pretty slow, but it's going to be noticeable in terms of the user experience, that it's not the experience they're going for, like the messages they're going to arrive late. So what LiveView does, so this is the other difference, is that we have the declarative model, but what LiveView does is, because it keeps a stateful connection, again, the WebSocket connection that you were talking about between the client and the server, LiveView actually knows, it understands your template, and it actually knows what the client has already seen. So when you add a new item to the to-do list, LiveView can figure out and say, hey, I can see that you already rendered 3 other to-do lists. So I want you to render just another thing just like that, but the values of this to-do list, like the to-do list name, in its place instead. So what we do is that we are actually sending the patches that I was telling you about. We're like say, hey, go change this on the page, except that you, the developer, you don't have to write it. The framework is figuring all of that for you. And there are a bunch of like LiveView-like solutions where they have the declarative model, but they are doing full page updates. And you can notice that they're doing full page updates because the user experience is not as good. So I feel like there are other like solutions, but I feel like LiveView, it's the main solution that allows you to both be declarative, which is the superior like developer experience, because you're no longer saying, hey, go and change this place on the page. You're not asking the developer to do that. So it gives like this superior programming model, but it also gives the superior user experience because it can actually send just minimal dips on over the wire and say, hey, just go and change this place. It gives you the best of both worlds. So, and that was something like that we always have been like very, very excited about LiveView. it can give you both. So the kind of applications that you can build, we keep telling people like, don't use like LiveView to build games because it should not be used for building games. And people keep building games and the experience, like people deploy a game in the United States, I can play here from Poland with the latency, and the experience is great because exactly when you get the declarative model and it's stateful and we can send like minimal patches over the wire, it allows you to give the next step in building like interactive real-time applications driven from the server. There's just one last example because I got really excited about this, but just to give you an idea of how cool this is, somebody was building a Trello clone in LiveView. And in Trello, like you have the cards and you can reorder the cards. And what they did is that when they reordered the cards, they went to see the payload over the wire or what was going to send. So when we ordered the card, instead of like, it did not send the whole page. It did not even send the whole column that you are reordering. It did not even send the contents of the card. It just said something like, hey, here are the new IDs that you should flip the content around so you get the proper order. So literally like just sending a list of IDs with the new instruction, like with the new order that you want. And that's it. And the developer did not have to hard code those instructions. Imagine if you are a Trello developer and if you want to build like a single page application, you would have to go on the client, implement the resorting logic, go on the backend, implement the endpoint that is going to sort and return a new order for you. So you can do like this very optimized flow. And here we didn't have to do any of that. You just say, hey, you just sorted the list again. And we would render the page again and would figure out, oh, you already have all those cards. Cool. Just flip the order and it's all done for you. So I absolutely love like this combination of being like declarative and stateful because the kind of things you can build with it sometimes like is just bananas.
That is super cool. What happens if two users were to sort at the same time? Is it able to like handle that for you, or do you have to implement some logic for that? Or
now we're talking about distributed systems, and there are like many solutions that you can take here. So I'm going to give you a solution which most people would do, and then I'm going to talk about the really cool solution. Okay. So what most people would do is that in this case, so the live view is per user, right? And again, it all goes back to the platform because if you say, hey, we want to keep a stateful connection between the client and the server, but that's only going to work if you have a platform that can stand like hundreds of thousands of people connected at the same time. So if you have two users, each user is going to be connected to their own live view. And then when one reorder, you are probably going to write to the database and you're going to send a message to everybody who is watching that page saying, hey, we have a new order now. Or you can send a new order again. It's up to you if you want to say, hey, you have to go to the database and get the new order, or if you just want to send a new order. But you're going to broadcast those changes. And also what's really cool, again, about the platform, about Erlang Virtual Machine is that you don't need to bring like external tools for that. You don't need to bring Redis. You don't need to bring any cable because again, remember like the Erlang platform was designed for building like distributed applications, machines that can communicate with each other. So we just communicate all the machines, we just connect the machines with each other and they exchange the information. So what we do is that we would say, hey, okay, I'm going to write to the database, the new order, and I'm going to send the message. So in your case, when two things like they change at the same time, one of the writes, somebody is going to be first, somebody is going to be later. The later is going to be the one that is going to be in the database. And that's likely what is going to be reflected at the end. But one of the things that it's important to notice is that this issue where we have to say like, hey, now I have two users trying to order the same thing at the same time. And what is the result that you're going to have? This is not specific to LiveView at all. All Trello-like applications, they are going to have this issue. But I love that when we are talking about LiveView and thinking about how things are going to happen live, it automatically puts us in this mindset where we can ask the proper questions. Because like people, they would write bidding actions, bidding platforms, and then like people can win the same auction, which is not possible. But when you think about, hey, those things are live, those things are happening at real time, it also puts you in the mindset where you think like, hey, what happens if two people do this action, which can always happen, but it puts you in the mindset to ask those questions. And I think that's very important too. So that was the canonical answer, right? We are going to write in the database. But there is another approach we can take. And for an example of this, you can look at Livebook. So Livebook is an application that my team at Ashbit is working on. It's a collaborative programming notebook implemented on top of LiveView. And it's fully collaborative. And we don't have a database because everything is in memory. So you can go there, you can like run Livebook in your machine. So you can run it in a cluster as well. People can connect to the Livebook and you can start like writing code together at Google Docs. As you would do like something like Google Docs, you can execute code. And then the same questions can happen as well. Like you say, well, what if two people try to run the same code at the same time, or one person tried to run it and the other deleted something? What is going to happen at the end? So what we do in Livebook, so Erlang has this feature called global. And it's so interesting because when you say about, oh, it's a global variable in Ruby, you think one thing, right? Like it's a global variable. But in Erlang, when we say global, it's global throughout the whole cluster. So what happens is that if you have like 10 machines together and you say, I want to start a new collaborative session, we are going to pick one of those machines and say, hey, the entity that knows everything about this collaborative session is going to be on this node here, on one of those 10 machines. And I'm going to tell all of the other 10 nodes that I am here. So now it doesn't matter where the other users are connecting from, which machine they are connecting from. They know like if they want to do some change to the text, if they want to like delete something to execute code, they need to talk to that machine and have that machine. So that machine basically like is where everything for that particular session, only that particular collaborative session where everything goes through. And that's how we do it. So now in this case, instead of having like two people potentially writing at the database at the same time, we are all sending to the same session on the server that is going to process everything that is arriving in order. But again, I don't know if this is clear, right? But you can think like, I'm going to give more examples on why this can be powerful. Some ideas. So for example, think about you want to build a game. Now, I'm not talking about a LiveView game, but think like I'm building a game, like a massive multiplayer game, and you need to have a server. That server is not writing to the database all the time. Every time the user shoots, right? Every time the user jumps. They have a cluster, and for every session, for every game that is playing, they have one of those machines in the cluster is going to be responsible for that game, and everybody's going to connect to a machine that talks to that machine. Again, it's the same design that we were talking about that we do in Livebook. It's the same design, the same idea. So you have one machine, people connect to the other machine, and that machine is responsible for that game session. And what is interesting about this is that if you want to talk to the database as you would in Rails or any other application, you can, and you can write to that. But the Erlang platform and LiveView also allows you to build those applications that looks like a game if you want. And so there are people using Elixir to build like game servers. That's an actual thing. There is also a very cool example from a company called Moz Analytics that again is like, it's very similar ideas to this. One of the services they provide is analytics. So analytics, you receive a bunch of data and you have to show graphs and reports for the data that the user wants to see. And their initial implementation of the system, what they would do is that every time they would say, hey, I want to see how many access I had from Brazil within those dates, it would go and do a database query. And that would be like super slow because they had to go to the database had to crunch all of the data, and then they would finally render that. So when they started working on a new solution and they were working with Elixir, they were able to reframe the problem and to design a database-less solution. So what they did was like, hey, you know what? What we're going to do is that we're going to pre-process, like we're going to get the data and we're going to put in S3. And we are going to get the data, and we're going to put like the data for the last like 6 months. And we are going to put that in S3. And then after a day of work, we put more data on S3. We're going to put everything in S3. And now when the user joins the application, the analytics application, instead of going and querying the database all the time for every iteration, because we have like those live sessions that can be running for minutes, for hours, like a game session or like a Livebook collaborative session, what they did is that they would get the whole data from S3, load into memory, and have the user interact with it. So now when the user say, hey, I want to like extend the range, they would like receive the request because the data now is loaded on the server and we have a direct WebSocket connection to that server. And now they would say, hey, I want to see this frame. They would just go and they would like change a filter. Like in Ruby, you would do like dot filter. They would say, oh, okay, let me just traverse the data now. They completely remove the latency of going to the database for all the operations. They just have to load the data once. And now as the user is using it, everything is immediate. So they said like, I don't remember the numbers, but they wrote a blog post saying like, with our new solution that is databaseless is things are now 20 times faster. Before, because of the constraints of the database, the user could see the analytics only for the last 16 weeks. And now the user can see the analytics for the last 6 months. So again, it's like the fact that it's fine for the platform, like to be stateful and have like things connected all the time and exchanging information and working with the data all in memory without having to go to the database, it opens up the possible solutions that you as a developer, you as an engineer, you have available to you. And when you have that, sometimes you can like completely rethink the solution to the problem and deliver something that is like much better for the user. I'm really going on a tangent here, but I just really wanted to drive the point about what the platform enables us. And there are many examples of how these possibilities we can use in different places. It can be in a Trello-like application. It can be on something collaborative like Livebook. It can be on analytics. It can be on a game. Or you cannot use any of that at all and just go and talk to the database. So I have sometimes people like, they tell me like they're a little bit worried because they are using Elixir and they're not using the advanced features. They feel like, oh, because I'm using Elixir now, everything like I'm never going to touch a database again. And they're like, no, it's totally fine. You can still totally use the database. And even if you're just saying like, hey, I'm going to use Phoenix and I'm just going to talk to the database, you're still going to have a better developer experience than the other platforms because that's truly the only two things you need. You only need Phoenix and the database. So remember when I was saying that I was like frustrated about web development, that I had to add Redis, Node with Phoenix and with LiveView. I only need my Phoenix application and the database. I don't need something like any cable for managing the connections for me. I don't need Redis. I don't need Node because we use things like ESBuild as well to compile the assets for us. So you only need Phoenix and the database. And I love that. And in the case of Livebook, we do not even use a database. It's just Phoenix. That's all we need. And I absolutely love that because as a developer, it means that if I want to start working on a feature, I don't need to, and something goes wrong, I don't have like 5 other different components to debug. When I have to put that in production, I can just run the application. And with the database, you don't have to set up other services. And for Livebook in particular, that we want to be like a programming environment, it actually allows us to distribute it as a desktop application. And without having other dependencies, I don't need to tell user like, hey, now you need to install like this other thing in the system, or we need to figure out like native compilation of SQLite tree. There's just a huge amount of problems that disappear by relying on a really powerful stack. And that's what I love about like working with Phoenix, working with LiveView.
I love it because LiveView is very interesting to me. One night, sat on my couch and just read Hacker News comments where Chris McCord was in there talking about how LiveView works. I was trying to like get as much context as I could because it's so magical to me. Something you said just now triggered a thought in my mind because often when I hear developers talking about different languages and say something like, yeah, I'm interested in Elixir or using Phoenix. Typically, I guess my context would be Rails developers. I hear this kind of differentiator like, oh, well, if you're building something that needs really good concurrency, use Elixir. Otherwise, just use Ruby. But something you said just now was using Elixir and Phoenix is just a great developer experience. Do you mind maybe just kind of touching more on that a little bit about like, what are the good cases outside of concurrency for using Elixir?
I really like this question because I think this is like kind of a cop-out if I'm going to be very honest about it, because it's a way for you like to compartmentalize why you don't need something. You say, oh, I'm just going to need that if I need this, and it's very easy for me to compartmentalize and say, okay, that's why I don't need it. So I think Elixir is going to, and it depends on the scope, but we can explore multiple of them. So I think like Elixir, first of all, it's going to be great for productivity. We can even start at the mechanical level. So I like to say, look, sometimes people would come to me and say, look, our test suite is very slow before Elixir. And then I would think like, hey, how many cores do you have on your machine? And they would say 4. And how many cores are you using when you're running your tests? And then they would like look at me and I was like, 1. And I'm like, yeah, there is a chance you can make your test suite 4 times faster and you're not using that chance. But that's because in a lot of the platforms, the tooling is not there. And today I say like, if I use any tool in my computer and I'm waiting on that tool to finish and that tool is not using all cores in my machine, I get pissed. I'm serious. I feel like I'm being disrespected because I'm like, hey, you can make things faster. You can make me wait less. So why are you not doing it for me? Like that's your job as a tool, is to respect my time. So I think like even the mechanical level, because in Elixir, everything is centered around concurrency. It's the opposite. Instead of like just part of the tooling being concurrent, like most of the tooling is concurrent out of the box. So even like from that mechanical perspective, it's already great from the productivity experience. We also talk about immutability. And I know that not everybody is going to agree with me, but I feel that software that has like immutability principles by default is going to lead to more readable software that is easier to maintain. So that's another plus in my book for Elixir and the other functional programming language too. Like this is not specific to Elixir. So yeah, you're going to be more productive in the long tail because I really believe you're going to write like easier to maintain software. And Elixir brought that culture from Ruby where it focuses on the developer experience, on the developer happiness. So sure, when you're going to compare with something like Ruby or even bigger like Python and JavaScript, you're going to feel like, hey, there is a package that is missing for this. But everything else, we totally compensate for it, like about the user experience, about the quality of the tooling and how easy it is to learn that. And it goes all the way, right? So it's not only about like writing the code and having the toolings be productive, but it's also about the development experience. It's about writing maintainable code. And when it gets to put into production, what we were talking about, again, like if you're building a Phoenix application, you only need Phoenix and a database. It's a bunch of like operational complexity that you no longer have to worry about. Like every time you onboard somebody to the project and it say, hey, you need to install this and this and this, or you need to have Docker to run all those things. And then when something fails, good luck figuring out which of our 5 component fails. You don't have any of that. So yeah, so I don't agree. Like Elixir is only for like the cases where you need like concurrency or need something to really go faster. I really think it can simplify your stack throughout. But I also want to be clear that it also doesn't necessarily mean like just go everybody and change to Elixir tomorrow. I think like from a technological point of view, we're really good. I'm really confident. But for the adoption of every technology, whatever technology in the company, right? Like if you're a solo developer, it's like, go for it, try it out, have fun. But when you're going to adopt at the company, then you need to consider everything else that comes with adopting a technology. So we hear stories from companies that, hey, we tried to use Elixir, like 3 people started doing Elixir and then these people left. And now there is nobody that is taking care of that. And that's what's going to happen with whatever technology if you don't take a holistic approach. If you say, hey, if you're going to start writing Elixir or whatever, use a new database, what is going to happen? Like, should we try to hire new people? How are we going to talk about this technology internally so other people of the company can get familiar with it? So you always have to consider all of those aspects that come with it. So I heard from people like, hey, we used Elixir, the people left and then nobody had to maintain it. But I also heard from companies that were really struggling to hiring because 2022, it's a great year to be a developer because everybody's hiring, everybody needs developers, whatever language. And they said that they were having trouble to hire in their previous stack. But when they said that they were doing Elixir it actually solved their hiring pipeline because people, they wanted to come just to be able to develop something with Elixir. So they're like, hey, we are going to be working with Ruby and Elixir or JavaScript and Elixir. And that was actually a differential for them. I expect that everybody who is listening to me know that I am obviously biased, right? Even though I try to not be super biased, but I'm obviously biased. But yeah, I think like technologically, we are super sound. And I think you're really going to get like great productivity and great development experience by using Elixir, Phoenix, LiveView. It's going to simplify our stack. It's going to simplify our application. And I hope you really enjoy it.
Yeah, that's awesome. Are there any rough edges of Elixir that you're still wanting to put some polish on and stuff?
That's a great question. I think it was the same Elixir conference that LiveView was announced. Maybe it was 2018. So this is 4 years ago. You would hear that a common problem with Elixir was deployment. People wanted clear instructions to deploy Elixir because Elixir, we have something where I don't think we have this in Ruby. But in Elixir, we have something where you can get your application, all of the dependencies, including like the Erlang VM itself, and put into a zip file. So you can put that in production. So you don't need to have like Elixir installed on the machine. Everything is in one place. So people wanted to have that. And that's something that we worked and we solved that particular problem. So it's no longer a problem that exists in the community. And the reason I'm bringing this up is because one of the things is that even though Elixir grew a lot, but it's not like super big, is that this communication channel between like the Elixir team and the community is still pretty much open, still pretty much accessible. So we can still be like a lot in tune with what the community needs and what they feel need to be improved. One of the things that I hear a lot of people saying, and I agree that we need to improve, is the junior developer experience. Because I can come here and I can talk about Elixir for people who have experience with web development, 3-4 years of experience. And a lot of these resonate. A lot of the pain say like, hey, we are solving this pain. We are solving this pain about complexity. Like it's simpler to deploy, simpler to operationalize. It's concurrent. So you had better tooling. It resonates to senior developers. And our materials, they are also targeted at somebody who have like programming experience. We do have like a few materials for people who are like just started with programming. Ruby has a lot of these, for example, through boot camps like JavaScript and Python, right? But we don't have stuff like I've never programmed before and I want to start programming now and I want to start with Elixir. So that's something that we need to work as a community, and it needs to be all areas, right? It needs to be, we need to have more materials. But not only that, we also need to convince companies that they should also be looking for a junior Elixir developer. So we need to take care of this whole pipeline. So I think that would be like one of the main things that we need to polish. And I know it's not a language level thing, but it's pretty much an ecosystem community kind of need, and that we have been focusing on the last year or so and working on these materials. And again, going along with the funny stories, it's very interesting because my brother is learning how to program and he started with JavaScript. And it's so funny because the things that he gets tripped, sometimes he would get tripped immutability. So he literally called me one day, he's like, hey, when do I call like array.delete, I think in JavaScript? Why does it change the thing? And sometimes it returns a new thing. And that was getting him confused. And then I was just thinking like, I know, right? Why people are doing that? And then the other thing he got tripped was returns in JavaScript that in Ruby we don't have. And then the return is implicit, which is great in Ruby. And the return is implicit in Elixir as well. It's like, why does it want me to return? Like he was asking me like, why does it just always return for me? And then I'm like, I know, right? So it has been really fun. And one of the things that I think the Ruby community, I don't know if you still hear a lot today, but part of the Elixir syntax was inspired by Ruby, which is something that is, when you look at it, you can see some similarities. And one of the things that sometimes I would hear back from in Ruby is that people would say like the syntax is a little bit foreign. And people could say the same thing about Elixir. And what has been like very interesting in seeing my brother learning how to program is that he never asked me a syntax question about JavaScript. I don't know why, it can be many things, but my theory is that he can solve the syntax questions himself. And I think my theory is that most of the syntax issues that he runs into, he gets the feedback early and then he can Google about it and he can solve it himself. But when it's something more about the semantics or conceptual, sometimes you need another person to be there and help him through the process. But it's actually not true. There was one syntax question that he asked, which is not an issue that would happen in Ruby, nor in Elixir, is that in JavaScript, you have like the parentheses are optional, but I'm doing like optional between air quotes because in JavaScript, when you don't have the parentheses, if you're calling a nullary function, a function that doesn't receive any argument, if you don't add the parentheses, it returns a reference to that function. So he was also tripped by that. Like sometimes he could have the parentheses, sometimes he could not. And that's not a problem that would happen with Ruby as well, because with or without the parentheses, the behavior is the same the huge majority of the times. So anyway, so it has been like really interesting to see somebody learning with, especially now that we are thinking like, how can we improve the learning experience for Elixir? But yes, answering more directly, that's definitely one of our big focuses is like, how can we make it the onboarding experience for like junior developers or people with like no experience or like 6 months of development experience in their belt? How can we improve that?
Yeah, that's really nice because I think in general, that is always the barrier to growing the community as a whole because you need more newcomers all the time. So it's really good to focus on that. And it's awesome that you are thinking about the language as a whole with the community and everything about it, the education and all of that. We've talked a million times about Laravel having a really good, they support their screencasters and all these products around it and stuff. And it just makes for a really good community that's attracting a lot of people. And I think it sounds like you're on the same path there as well.
Yeah, I really like you brought up Laravel because I also think that exactly that. They are a great example of trying to be like all encompassing and trying to onboard everybody on everything, right? On all the different angles and throughout all the way.
So you spend a lot of time, I assume to be a lot of time, because you have quite a few commits in Devise. And one of my, I'll just call it a hill I'll die on, is that I really want authentication in Rails baked in to the point where we've talked about that with the framework founder on this podcast. That is pretty recent for Phoenix, a recent topic, because if I'm not mistaken, you recently yourself explored this and came up with an option for people to quickly scaffold authentication in Phoenix. And I would be kind of curious just to hear your thoughts on supporting authentication in a web application.
So the thing about authentication is that even though we want to try to say like, hey, I want somebody else to solve that problem for me, at the end of the day, it is part of your business logic. It's part of your application needs, and your application is going to be the one that knows about it. So there is no way around that. And when you look at Devise, we try to give you everything, but still make it customizable. And so you can tailor it to your needs and everything that you need. And the issue with that is that, one, we have way too many options. And how those options, they interplay with each other, it can be like very confusing ways. And then part of the options is like using inheritance to customize how our controller works. And that generates like sometimes of weird coupling because now there's a new device version and that may change something in that controller that we were expecting to happen in some very specific order. So I feel like Devise is trying to solve everything. It was great to see like what works and what didn't work. And so for me, like the way of doing authentication, get everything that in a framework is get everything that is related to authentication, but it's not part of your business logic, and encapsulate that into a library, something beautiful that is easy to use. So for example, like Bcrypt that I know Ruby has, like get the password concerns. If your concern is like token generation, solve token generation elegantly. If it's sending mail, solve that piece. So everything that is left around authentication, everything that is left around it is what is part of our business logic. But then there's the question, how are we going to provide that to the user? So the realization I had with Phoenix and today's part of Phoenix is that the best we can do is to generate that into the user application. And because we have shrunk, like we have encapsulated everything around that, the amount of code that we have to generate is not a lot. So we're going to generate that code to the application, what is very security centric. We are going to explain what is security, why that code is security centric, and have that as their starting point. So in Phoenix today, we have authentication baked in, which is a command that you run, and then you can run it like 10 times if you have like 10 different types of actors in your system. But it's a command that you run that is going to generate some controllers for you, what we call context in Phoenix, which is basically the model layer. Not the model as we think in Rails, but the model layer as a whole. And the functions for you to interact with that. And what is really essential, because the other thing about authentication is there are security concerns, right? And we want to make sure that we solve those things properly. But more importantly, we want to make sure that the user is not going to mess with it, because now it's in the user application. The user is not going to mess with that in a way that is unsafe and add a vulnerability to their code. So it's about encapsulating that as much as we can and giving the code to the user and say, hey, this is what you need to get started. If all you want is to get a project up and running in 2 days because you have to do a proof of concept for somebody, it's definitely going to get you there. But in the long term, you're going to have to evolve it. Because I don't know about here on the show, what is your experience with Device? What are your feelings? And maybe I don't want to know either. But what I've heard a lot of people saying though, like Device was great for us to start, but a year later on, I just wished so much that I could yank all of it and just let me do the changes to the code. I heard this so many times and I agree. And the idea we took with the generators was maybe it's our approach to have the cake and eat it too. It's like, well, maybe we are going to keep it minimal, generate the starting point to the user, and that's it. So people say, hey, what about like two-factor authentication? What about this? Like, no, we're not going to add that. The good thing about having the generator as well is because it also adds like the starting point. So if somebody wants to write an article on like how to do two-factor authentication, they have the common scaffold structure that we can say, hey, run this, and now do those changes and teach people. So that was my thoughts on authentication, 10 years after Device. And maybe in 5 years, we'll be like collecting the lessons of what went wrong with this approach. But if you ask me today, like if you're going to ask completely unrelated to Elixir or Ruby, what is the approach you should take for authentication? I would say this is the approach you should take.
I absolutely loved that because I would say I'm pretty pro Device, similar to the experience people have shared with you before. It just feels at times like it is doing a lot. And so I really appreciate you answering that and sharing just because of your history with it. Like you said, like 10 years of working around authentication, because my concern so much, like I'm lazy. I will give you that. But it's not so much about like I want somebody else to do it all for me. I just worry about what do I not know about authentication? What kind of holes am I going to dig myself into where I could be vulnerable? And so I think the approach with the generator and keeping the secret things tucked away, or if they need to be exposed, explaining it is so fascinating. So I appreciate your thoughts on that.
We had Raphael on the show a few weeks ago, and we asked him our question of, can we have authentication in Rails? And he described his idea of what he thought would be the best way to do it. And it's almost identical to what you just described, as in having generators that scaffold out things. It's not built into the library. It's provided to you, and then you can build on top of it. So now I'm really curious if he came up with that idea on his own or if he saw what y'all were doing.
Yeah, that would be a fun chat to have. I was going to say, like, the thing about Device is that it's very easy for people to like fall in love with it after you run it and they're like, oh, it gave me all the same. But I think the issue is that a lot of people like fall out of love with it in the long term. And I think that's part of the struggle there.
What are you working on lately? Is there anything new and exciting happening?
So just to tie it up, we talked a lot of things about Elixir. And I think it's kind of natural that we focus a lot on web because we have like this shared background with us. But one of the things, like I was telling the story and how I didn't want like Elixir to be tied for the web. I always felt it was kind of like one of my responsibilities to try to incentivize like people to get Elixir out there and use it for different kind of stuff. And also like myself try to bring like Elixir to whole new domains and whole new areas. One example, like sometimes people ask me like, what surprised you the most about Elixir? And my answer is always nerves. But by the way, I'm not answering your question yet. I'll get there. So nerves is a framework for building like high-end embedded applications, like something that would run on a Raspberry Pi, BeagleBone back. So like they are like fantastic applications of Elixir being used for that. So like Farmbot is one that I recommend everybody to check out, which is literally like a robot that takes care of a small farm and it's programmed in Elixir and it talks to the server that is running Elixir as well. So it's a very interesting way. Like some people will talk about like, oh, JavaScript running on the client on the server. And then when you go to embedded, there are people choosing to use Elixir for embedded because you can use Elixir for the embedded part, controlling the robots and the server as well. So there are a bunch of cool nerves examples. We can link to the nerves framework. And I always bring it up because when people ask me like, what is next for Elixir? Like, what should I work on? And I was like, don't ask me, like, do what you want to do. Because if somebody asked me, I would never say, hey, Elixir is going to be really good for building embedded systems, which if you think about, it actually makes total sense. And I know at this point, like people hearing this, when I say the word platform one more time, they're going to want to shoot me. But if you think about it, like when Ericsson built Erlang for telephone switches, Erlang was running embedded. And when Erlang is running telephone switches to power like LTE, 3G around Europe, it's all embedded. So they got that and they're using Elixir, they're using Erlang for building high-end embedded applications. So that's a very nice use case for Elixir. And then with time, we have a framework called Broadway that I worked with my team for like building like concurrent data pipelines, data processing. So what I'm trying to say here is that I've always tried like to bring Elixir to new areas. So we are not tied to like being web specific. For example, I really like Python and how they were able to be like to grow to so many different areas. I was invited to speak at a Python event in Brazil. And it was so fascinating to see like how you had people doing all different kinds of stuff, like all there in the same event and exchanging ideas. So to answer your question now, after that huge introduction, so a little bit more than a year ago, we announced a numerical Elixir, which is a whole effort about making Elixir really good for like numerical computing, machine learning, and this kind of stuff. Build the whole ecosystem around it. And I really want to build it like when I take these approaches, I want to build like a holistic approach. We could easily say, hey, you know what? We are going to talk to Python. And that's fine if you just want to talk to Python to get a solution quickly running. But I want like to build the whole infrastructure on the platform so we can better leverage everything that it has for us. So I started working on this like numerical Elixir effort. And we announced a project called NX, which allows us to work with like large matrices of data. And that's what I have been working on for the last almost a year and a half. And a lot of my effort is into that. And it's really cool. Like, because if you asked me when I started Elixir, what you can do in NX, for example, you can actually get a subset of Elixir. You can get a part of your Elixir program and compile that to run on the GPU, which is like super cool, right? You get the language or get part of that to run that in the GPU. And if you asked me like 10 years ago about that, I would 100% not believe. No way. I would not even know where to start. So yeah, we're working on this whole effort. So we have like a collection of projects. So we have NX, which is numerical Elixir. We have Axon, which is like for building neural networks. We talked about Livebook. And when we started Livebook was in this context of having like collaborative applications, because in Python, they have something called Jupyter, which is very common within like data science, data analytics, data engineers. So we wanted to have a tool for Elixir, but that leverages like all the collaborative powers of the platform that we talked about extensively throughout the episode. So yeah, I've been working on this thing for the last 1 year and a half, and I'm being like very, very excited about it. I was at a point where I was like, I don't know much what I was going to do with my life. Elixir is kind of like for the web, it's going great. There are great people leading it. People are taking it for embedded, and I have zero input in that, and they're doing an amazing job. And I was like, maybe I'm going to rest my laurels, right? And then by a coincidence, we collided on like doing this numerical Elixir thing. And I've been like absolutely enjoying it to the point that in the last month, like I had an arm injury from overwork. So I'm kind of like, so you're saying, hey, we should be fast with the record. Like, don't worry about it because I cannot work. I cannot be typing. So, being on the podcast is also great because I get to talk and take my hands off the keyboard. So yeah, that has been like my passion for the last year and a half. And if you are into machine learning or anything related to like work with large amount of data, numerical computing, or even mathematics stuff, come check it out. Hopefully you can join us and help us build this whole other huge area that we hope Elixir is going to find excellent use cases for as well.
That's super cool. There's so many things these days. I feel like it just gets more and more where everything needs to communicate with everything else in as real time as possible, that it just makes perfect sense. Like Erlang was such a good foundation, and then you can go build on top of that and effectively like modernize it all. And yeah, you'll probably just always be surprised with, oh, this makes perfect sense for Internet of Things and other stuff you never even imagined. So that is so exciting. One of the things that's been on my to-do list to look into Elixir forever, and I played with it a few times. I think some of those things where it's like, look, these are hard to do in Ruby. I know Andrew Kane's been doing a ton of work on machine learning stuff for Ruby because that's one of the things that Python's very popular for. Ruby is not. It's just cool to see all this stuff happening because that's going to become a staple of, for a long time, you were building web apps and they're pretty standard CRUD, but now you pretty much have to build something that updates things in real time, no matter what you're building. And you're going to end up using machine learning. We will always end up making more and more complex applications. So it's awesome to have tools and things that just make that easier for you to go build the business products and things and not have to worry so much about like all the underlying technology. It just really brings it up a layer of abstraction, which is awesome. So huge thanks for all the work that you're doing. And I feel like it's pushing everybody forward, which is awesome.
I feel like there's like 50 more topics I want to talk about, but I want to give you an opportunity to share anything you want to share, links people can find you on the internet, any cool projects, things like that.
You can find me as José Valim pretty much everywhere. I am usually not much on social networks at all. If you want to check cool things out that we talked today, and I already talked about it, but you can try out livebook.dev because it's going to give you a preview of a bunch of things. You're going to be able to play with Elixir. You're going to see like how a live view application can actually like look in practice and how it can be made collaborative, and it can really look like, a state of the art single page application, but with the minimum amount of JavaScript necessary. And just to close everything up, I talked about like one of our challenges of like how we want to onboard more people into Elixir. And I think Livebook, I hope it's going to play a very big role in that, because if you have an environment that you can install as a desktop application and that gets you to run Elixir in your browser, and then you can type things, you can try out, you can connect to the database. Maybe you can run like some image classification examples. Maybe you can do like all those crazy things that should be able for you to do with Elixir in the future. And you have this immediate feedback. I think it can really be like a great tool. And that's why we have been working on Livebook. We have been like very excited about it. At my company, we have like 3 people working on Livebook right now because it can be one of a great differentiator and help Elixir continue growing in all kinds of ways, to new people, to new domains, and so on.
That's awesome.
Thank you so much for having me.
Yeah, thank you so much for joining us. This is a blast.